In an algebraic expression, a term is a number, variable, or product or quotient of numbers and variables. A monomial is a term that does not include division by a variable, so it's simply a product of constants and or variables. Monomials have the form ax to the power of n, in which a is a constant and n is a whole number. A polynomial is a monomial or a sum of monomials. Let's look at some expressions shown and determine whether or not they are monomials or polynomials. First, look at these 6 expressions in the middle of the slide. The expression 5x to the 4th clearly fits the pattern of ax to the power of n, so it's a monomial. What about simply the variable x? Well, this expression is a monomial as well, because we can think of it as 1x to the first power. So it matches our pattern of ax to the power of n. Even a constant like 4 is a monomial because it can be written as 4x to the power of 0. Monomials can have more than one variable, so the expression 0.3x squared y is also a monomial. However, our next expression, 8 over x, includes division by the variable, so this expression is not a monomial. And our final expression, 1/2 x to the 3rd power, once again, is a monomial since it fits the form ax to the power of n. Now let's look at the 5 expressions shown on the bottom of the slide. The expression 2x plus 1 is a sum of 2 monomials, 2x and 1. Therefore, this expression is a polynomial. 7x to the 5th is a monomial itself, and by definition, that means it's also a polynomial as well. Negative 6x squared plus y minus 9 is a sum of 3 monomials. Therefore, it is a polynomial as well. Our next expression, 3x squared plus 4 over x, contains 2 terms, but only the first term is a monomial. The second term, 4 over x, includes division by a variable. So this expression is not a polynomial. And finally, our last expression, the quantity x plus 5 over the quantity x plus 10, is also not a polynomial because it includes division by the variable x. Now let's look at some names of polynomials. A polynomial comprised of 2 terms is called a binomial. A polynomial comprised of 3 terms is called a trinomial. But polynomials with 4 or more terms have no special name. Let's look at some examples. Our first expression is 3n squared minus 2n plus 6. We can see that there are 3 terms in this polynomial, so it's a trinomial. Our second expression, negative 10y to the 4th, is simply a monomial. The third expression, 5x to the 5th minus 3x cubed plus 2x squared minus 4x, contains 4 terms. So it doesn't have a special name. We simply describe this as a polynomial with 4 terms. And finally, our fourth expression, 6x cubed minus 11x squared, contains 2 terms. So this is a binomial. Now let's consider a few more definitions. The constant part of a term is called the coefficient of the term. The degree of a term is the number of variable factors in that term. And the degree of a polynomial is the same as the degree of the term having the highest degree. To help understand these definitions a little bit better, we're going to complete the table shown for the polynomial 9x squared minus 5x cubed plus 4x plus 7x to the 6th minus 8. Notice that this polynomial contains 5 terms. The first term is 9x squared. This term has a coefficient of 9, and it has a degree of 2 because there are 2 variable factors, 2 x's multiplied together in that term. Now it's customary to consider terms to be separated by plus signs. So instead of minus 5x to the third, we can think of plus negative 5x to the third. And so our second term is actually negative 5x cubed. This means it has a coefficient of negative 5 and a degree of 3, since there are 3 variable factors. Our third term is 4x, so it has a coefficient of 4 and a degree of 1, since the exponent there is 1. Our fourth term is 7x to the sixth, having a coefficient of 7 and then a degree of 6. And once again, instead of minus 8, we would think of plus negative 8, so our final term is negative 8. This term has a coefficient of negative 8, and then since there are no variable factors in this term, we say that it has a degree of 0. Now to determine the degree of the polynomial, we simply look at all the degrees of the individual terms, and we can see that the highest degree is 6, so the degree of the polynomial is also 6.